Now that you understand why design reflective code matters, let's explore how to achieve it. The transformation comes down to three fundamental pillars that work together to create code that truly reflects your problem domain. The first pillar is to hide your assumptions, or as we sometimes call it, encapsulate your secrets. Every implementation detail you expose becomes a constraint on future change. The key insight is to identify decisions that are likely to change and hide them behind stable abstractions. Let me explain what I mean by assumptions in this context. An assumption is any design decision that could reasonably change without affecting the core business logic. These are typical implementation details like how data is stored, what algorithms are used, what external services are called, and how calculations are performed. Here's a concrete example from an e commerce system. Let's say you have an order class. A non reflective approach might look like this. Let me walk you through the assumptions this code exposes. First, we're exposing that discounts are represented as a list of doubles. What happens when the business comes to you and says, we need to track why each discount was applied? Was it a coupon code, a loyalty program benefit, or a volume discount? Suddenly, every part of the system that touches this public list has to change. Second, we are exposing that order status is represented as a string. What happens when the business adds new statuses or when they want to add status specific behavior? Every place that checks the status string needs to be updated. Third, we are exposing the exact algorithm for calculating discounts, a simple subtraction loop. What if the business decides discounts should compound differently or that certain discounts shouldn't stack with others? We've leaked multiple secrets, and each one constrains our ability to evolve the system. Now, here's how we hide these assumptions. Now, look at what we've achieved. The order class doesn't know how discounts work internally. It just knows that it has a discount policy that it can apply to the items total. The internal logic of that policy is a secret, hidden away, free to change without affecting the order class at all. Similarly, the order doesn't know the specific details of order statuses, representations, or transition rules. It delegates status related questions to the order status object, which encapsulates all the complexity of status management. When a business comes asking for those new discount features I mentioned, the changes are localized to the discount policy implementation. When they want new order statuses, the changes stay within the order status hierarchy. The order class itself remains stable. This is the power of hiding assumptions. By identifying what's likely to change and putting stable abstractions in front of it, you create code that can evolve gracefully over time. The second pillar implements what's known as the open closed principle. Your code should be open for extension, but closed for modifications. You should be able to add new functionality without changing existing working code. This principle is transformative because it changes how you think about software growth. Instead of viewing new requirements as modifications to existing code, you start viewing them as extensions to existing systems. Now, let me show you what this looks like with a report export example. The non-reflective version is a classic big conditional block. Now, this approach has several problems. Adding a JSON export format requires modifying this method, which means touching existing working code. The method violates the single responsibility principle because it knows about PDF generation, CSV formatting, and Excel workbook creation. As you add more formats, this method grows longer and more complex, increasing the risk of introducing bugs into existing functionality. Now, the reflective approach introduces what I call a plugin model. We define an interface that represents the concept of exporting a report, and we create a way to register new formats. Now, each report format becomes its own focused class. And if you need to add a new format, it becomes incredibly simple. Now, let's look at what we've achieved. Our report exporter is now stable. It doesn't need to change ever, even as we add dozens of new formats. Each format is developed in isolation, tested in isolation, and can be maintained by different team members without coordination. We've transformed a closed system into an open one. This principle applies everywhere in software development. Whenever you see conditional logic based on type or mode, you have an opportunity to introduce openness through interfaces and polymorphism. The third pillar focuses on what I called complexity ratchets, design choices that make future work progressively harder. A complexity ratchet is a structural decision that clicks complexity into place, and it becomes very difficult to undo. Each new feature or requirement makes the system disproportionately more complex. A classic example of a complexity ratchet is using Boolean flags in method signatures. Now, let me show you how this anti pattern evolves over time and why it's so destructive. Imagine you're building a notification service. The first version is simple. Then the business asks for SMS notifications too. This still looks manageable, but then they want to go ahead and add push notifications and then Slack notifications. Now, look what happens when you use this method. What does this call mean? Which Boolean controls which notification type? You can't tell without constantly referring the method signature. Worse, every time you add a new notification channel, you have to update every single call site in your entire code base. If you have 50 places that send notifications, adding Discord support means adding touching 50 plus locations. This is a complexity ratchet in action. Each new notification type makes the system disproportionately more complex to work with. The design reflective solution introduces a unifying abstraction that eliminates the ratchet. Now, each notification type becomes its own focused implementation, and the usage becomes clean and maintainable. Now, adding Discord notifications means creating one new class that implements the interface. No existing code changes, no call sites to update, no Boolean parameter confusion.